Okay, so as we get started here, one of the aspects we have conflicting schedules moving forward. So what we had planned today and tomorrow, we will move back to next week. So with that being said, or just mentioning that, we will move on to that of the alkynes. So this does it for what's called aliphatic carbons, okay? That means non-aromatic structures. So what we see here, well, I should say we still have the alkynes left, but we left off with combustion, just like what you would have done in general chemistry. You have carbon and hydrogen, okay, being oxidized by adding the oxygen, and then getting the same byproducts, carbon dioxide and water. Okay, so then moving on to the alkynes, we know that there's a triple bond somewhere in the location of this compound.
Yeah, we haven't done combustion yet.
Oh,
Oh, wait.
there might be a gap there.
There should be an oxidation of. Oh, wait, yeah. Okay, oxidation of alkenes.
Okay,
Yeah, that's.
that's where we start.
Yeah.
Oh, okay. Okay, now we move on to our triple bonds, as we know, is going to be that of alkynes. And with that, those take a similar path when we apply Markovnikov's rule, and that's what one of your papers had dealt with. And the reason that we know that can happen is because we know that hydrogen will look for the compound or the atom that has the most hydrogen on it already. And that's how we deal with, again, Markovnikov's rule. And we can show you, because it was in the book, I said you could use that as a reference. Maybe some of you had done so. And then we can also show what happens at a later time. And then we saw an example of that. That was the last question on one of your homework assignments, the simplest, okay? And we would, and you had seen that it was hydrogen halide, or HCl, okay? Or you could just have maybe something like bromine or chlorine reacting with these. And this is something that we don't go into. We just keep it simple, the asymmetrical reagent or the symmetrical type. And then we don't go into some of these complex compounds. That's something you might do at the next level, and I really don't know how common that would possibly be. So then, now when we get to the end of that, that does it for the aliphatic compounds. Now we move on to aromatics, okay? Because aliphatic compounds, these are your alkanes. Of course, these are your alkenes. And then here's your alkynes. Aliphatic means just straight chains. They can be branched or they can be ring structures. Aromatics is a little bit different. The closest relation that we could see would be that of double bonds, because all aromatic compounds are based off of this substance, which has a formula of C6 and H6. Starts with the letter B, and it's benzene, okay? When we're talking about aromatic hydrocarbons, we are referring to benzene. So notice that we see aroma in here. A lot of these compounds give off pleasant odors, and that's why we call them aromatics. And benzene is actually one of them. It was a very good solvent that people probably used for years. But with many types of substances, why may something be discontinued, do you think? It must cause problems and or cancer. Okay, and that would be the case here as well.
Can you go back a little bit?
Mm-hmm. Okay. Okay. Now, look at what this last statement says. They have exceptional stability. Why would we say something like that? And that would be as follows. For aliphatic compounds that we've discussed so far, we'll just keep it really, really simple with maybe propene. Okay. So we know that is this highly stable or highly unstable? In other words, let's look at its counterpart. Which one of those two is more stable? The bottom or the top? Okay, so propane, if you're going to chlorinate that, as we learned before, oops, Cl2, and if we're going to do that up here, of course, as we know, as we're looking at these, which one of these reacts? The top or the bottom? The top will, because this is just too stable because it's saturated. But once we add something like this, now it will react where it have to have a catalyst. This you do not, because this is highly unstable because of these pi bonds here, alpha bonds there. Okay? On the other hand, when we look at aromatic structures, okay, this is not how we typically write benzene, but you can. We see, well, we know we've got these double bonds in here. Well, double bonds must mean instability. That is not the case when it comes to benzene. And of course, sometimes we write it like this. The circle means that there's those alternating double bonds in there. Okay, so the aromatic structures are highly, highly stable, okay, as opposed to unsaturated hydrocarbons. Okay, I want to get through this, that, and try to get down to there. Then that will be it for today, because I don't want to inundate you with a whole lot of information. So what we mean by this exists as both benzene and a wide variety of other compounds. Those are that reaction chart that you are given, or flow chart if you want to call it that. That's what this is referring to. Okay. So we see C6H6. We know we're talking about benzene, and that's the only compound we could be talking about when we see that, because if it's C6H14, we know it's hexane. We know that if it's C6H12, okay, that you would have to be maybe a little more careful, because that could be cyclohexane, or it could be hexene. That's where we had talked about constitutional isomers, where we're crossing different types of families. For our purposes, that's how we had stated that. And now, if you have C6H, see, I got to think about this, H10, then you're talking about hexine. Then finally, C6H6 is just that of only benzene. Okay, so then moving forward. So all aromatic compounds, notice if it gives off a nice fragrance, if it has benzene in it, typically it's probably going to give off a nice aroma. It's not the only compounds that give off nice aromas. Esters do that as well. And that's something we learn perhaps moving closer to Christmas break or right after Christmas break. We talk about a process called esterification. And then, like I said, I want to get down to this, and then we'll stop there for today. I'm glad we're cruising right along here. It's not quite 9 o'clock yet, so it gives us a little bit of time to process what it is we've talked about. And then these two probably, when we write these up on the board, you're going to say, okay, I remember these, because we do talk about this in general chemistry. So tomorrow will be your Friday, if you want to call it that, or last day of the week. We will have you try to remember to remind you to grab a book before we get started, because we will be utilizing that tomorrow. Okay, so does everyone have this content that is choosing to write it down? Okay, so we'll talk about both of these. Okay, so what we mean by that is there's our benzene. Okay, go ahead and get rid of that for now. Okay, so if we're just naming these compounds, it had said you're going to get really good at drawing six-sided figures here. You would think I'd be better at it, but sometimes they come out all right, sometimes they don't. So what it had said is you name the derivative on there and then say benzene. Okay. So then the top one, what type of group do we have on this benzene ring? It's a halogen. Yeah. So here we just have, very simply, chlorobenzene. Because it had said you name the benzene and then anything that's branching off of that. So with this was one of the examples on the bottom. It actually has two names. If we follow this system, which we can, okay, we know that it's benzene. And then what type of derivative do we have on here? Yeah, so we could just call that methyl benzene. Okay? But a lot of these compounds were named before there was a type of derived or universal system. So it's also got what we say is a common name. And it's not the first time that we had discussed something like that. They appear in chemistry more often than what you think. We could say something like this. Oh, not vinegar. Okay? Because a lot of that, now you don't need to be writing this down. We're just giving examples. Okay? Because that is this compound. We would say vinegar is acetic acid. We could say that this is ethyne, but we call it acetylene. So sometimes these compounds just have more so common names than anything else. So this also has one, and we know that it's toluene. Toluene, I say toluene. I mean, you're probably going to come up with very similar ways of pronouncing that, and I don't know which one's right. You can say, well, I suppose whatever you're more comfortable with, because if you say this to anyone else who knows anything about organic chemistry, if you say toluene, they'll probably say, oh, you mean toluene? Or if you say toluene, they might say, oh, you mean toluene? So there's really no one right way to name that. Just We could just say, that's just how I pronounce it because that's what it looks like. Then there is one more compound on there, and it was also a benzene structure, but I can't remember what it was. Phenol? What was it said toluene, what was the other one?
Methylbenzene, oh yeah, phenol.
And phenol, okay? So this, you could say, also has two names, okay? So if we did not call this phenol, what else do you think we could call this? What type of group is this? Non-alcohol. Hydroxy group. We could also call that hydroxybenzene. Hydroxybenzene. Okay. Now, do we have to be putting numbers on these? Do we need that? Do we need that? Do we need that? No.
No.
No, you do not. Okay? It's just understood. The only reason that you'd have to have this number on there is if we maybe put a chlorine up here. Well, then you would have 1, 2, and then dichlorobenzene. Okay? If there's more than one derivative on there, then you have to put the number 1. Otherwise, it doesn't matter where you put it on the ring. It's just going to be understood that wherever that's at, even over here, even on the bottom, it's just on the first carbon here. If you were to write phenol, chances are you're always going to put that up on top. If you write toluene, chances are you're going to put the CH3 up there. And that's fine. Okay, so that's all I have. We will catch up to you next time, which is tomorrow. We'll grab our books because there's some more naming of these compounds we need to go over. All right, we'll catch up to you next time.